Hi there, Miss Lambs here. Today, we would like to talk about the spread plate method. So what is spread plate method, in the microbiology? So spread plate method is to measure the diameter of the inhibition zone in order to assess the antimicrobial property of your substance. So for spread plate method, generally speaking, there are two main methods. One is called the 1A biofilm method, and then one is 1B. So the basic differences is that for 1A, it takes 2 days for it to form, but for 1B, it takes 1 day only. So let's walk you through as to how it works. So first of all, you pour some agar into the petri dish, and then you add some fixed volume of the bacteria onto it, and then you use a cell spreader to spread it, After a while, you put it in the incubator for 24 hours for the biofilm to develop. And after biofilm, a uniform biofilm is developed, then you place your antimicrobe substance, this paper disc, onto the agar. And then you wait for another 24 hours and then observe the inhibition zone. So that means an inhibition zone is a region where there's no bacteria or very little bacterial growth onto it. So and then next one, 1B, is that you prepare the agar, you pour your bacteria solution in, and then you use your cell spreader to spread it, and then you place your paper disc, antimicrobe paper disc onto the agar on the same day, and then you incubate it for 24 hours to observe the diameter, of the inhibition zone. So generally speaking, there are two ways, If you ask me what is the big difference, is that the difference is that the first method has some time for you to form a biofilm, but the second method is that you put the disc on the same day as your incubation. So which one is better? There's no which one is better. It depends on your experiment. But generally speaking, if you know that your antimicrobial substance is very strong, then perhaps you can also try 1A, where it forms a biofilm, where your strong antimicrobial substance can actually kill some bacteria, from the bacterial growth. But if you know that your substance is slightly weak in terms of the antimicrobial properties, then I will recommend 1B. So you place the antimicrobial substance on the agar on the same day. Yes. Because of copyright issues, I could not play this video in this video. But this is actually a video of how to do the spread plate method. It's done by the Microbiology department at the University of Lincoln, UK. I will also put the link in the video description below, and then you can click on it and see how it is done. So for 1A, what are we expecting? So if, for example, if I conduct the 1A, we form a biofilm before we place the antimicrobial paper disc. So that's what we expect to do. So once the biofilm form, this becomes opaque, no longer transparent, right? Now you can see that our 4 plates, they're not perfect. For example, this one, you can see that half of the plate is not spread properly. Now the reasons could be many reasons. For example, not enough bacteria volume, or perhaps when you place the disc was tilted on one side, so there's an uneven spread of the bacteria or solution onto it. There could be many reasons. So that's another reason why we recommend students to do 1B rather than 1A. It's because after 24 hours you discover, actually I can only use half a plate, then that may affect your plan. So yep, and then this one is okay. Definitely this is the perfect one. There's some edge that you cannot use, but generally speaking, we place our paper disc in the center. So that should be fine. You can still use this plate. So there you go. And this one you can still use maybe only half a plate only though. So and then this one is what it looks like for 1B. So you place the paper disc on the same day as your incubations. So what I did is I used some lead nitrate, very strong concentrated lead nitrate, which will kill, is toxic. It will kill the bacteria. As you can see, there are some inhibition zone around it already. So you can see here. Of course, some of them doesn't show very clearly. So for example, we can see the next slide. So this one is with the lead nitrate, which is toxic. So antimicrobial. And this part is just a control, which is distilled water. Actually, this distilled water plate, not all of them work as well. We'll explain in the next slide. So here is the one with the lead nitrate. Okay, so what you do is once you got this result, you measure the clear region. Okay, so with the longest diameter. Okay, so what you can do is you flip the plate and then you mark it from the bottom. It will be clearer to see at the edge. Okay, at the bottom of the plate. Okay, and then you use a marker to trace around it. Okay. And then if you find the black background is not easy to read, you can also try using the cell Coney counter, okay, with the backlight, which may help you to easily identify the inhibition zone. Okay, so you can see that. All right, so yeah. And then there's distilled water. Now, for the distilled water, we do expect some very mild inhibition zone, okay, because actually water can dilute some of the bacteria, so possibly that's the reason why we'll have some inhibition zone, okay. But here, out of all 4 plates, not all plates can be used. Now, for example, the top, if you look at the Coney counter top left, okay, there's no biofilm form, okay. So if your plate looks something like this, then you cannot use this plate because you cannot measure the inhibition zone here. Okay, same for this one. Okay, so the next one, only one of them can be used. Okay. And then for the bottom one is much better. Okay, you can see that there's a biofilm developed. Okay, so therefore you can still measure the inhibition zone for this one. Okay, so again, so for microbiology, you need to have the mentality to be ready that sometimes the plate didn't work as expected, and you need to do a few more trial. Okay, next one. So this is a summary of the spread plate method. Okay, so yeah. All right, so this is just a summary comparing the pour plate method from the previous video and today what we talk about the spread plate method. Okay, so you can pause the video and read this diagram in details. But actually, when deciding which method to use, there's a lot of factors we've mentioned in the previous video, such as the concentration of and volume of your bacteria, of your antimicrobial substance. Okay, you need to test them out a few times. And then also, even apart from these factors, you have to think about your methods. Okay, so are you going to use 1A with the biofilm method, or are you going to use 1B method, or is there any adjust in terms of your method, things like that we've previously mentioned. So here are just few things to remind you. For example, whether your antimicrobial substance is soluble in agar and so on, or the color of your antimicrobial substance, is it too dark or too pale to see the differences. So apart from the 2 main methods, the pour plate method and the spread plate method, what are the other possible way to measure the bacterial growth is the turbidity. So measure the turbidity of the solution. So let me walk you through a little bit. So what you do is you have some nutrient broth, okay, and then you add some bacteria onto it. So once the bacteria is added, you will notice that the nutrient broth is slightly cloudy, okay. So the cloudiness indicate the amount of bacteria that's available inside the nutrient broth. So afterwards, you incubate it for 24 hours, and then we expect the nutrient broth to become more cloudy. The reason is because the bacteria has multiplied, okay, so have cell divide a lot, okay, so therefore the nutrient broth become more cloudy. So by measuring the differences of the cloudiness, we can indirectly measure the bacterial growth. There are 2 machines that you can use to measure the differences of the cloudiness using the objectively, okay. So it's the spectrophotometer, okay, or the calorimeter. Okay, so and then what you do is you measure the percentage of transmittants that pass through the solutions. Okay, so what you do is you have some light. The idea is that there's some light source and then there's a sensor that detects the light that pass through. So if it's transparent, then a lot of them, as you can see, the uninoculated tubes, that means just pure nutrient broth. Okay, then most of the light can pass through. Okay, so the percentage of transmittant will be like close to 100. Now, once you add the inoculated nutrient broth, so that means with the bacteria, now the bacteria cause the cloudiness, so not a lot of light can pass through. So you can see that the percentage of the transmittant will be decreased. Okay, all right, so that's the idea. One more thing, be careful in the machine, is that there's 2 functions. One is called absorbance, one is called transmittance. Now, in this case, you should be using the transmittant because you're measuring the level of cloudiness. Generally speaking, we use the absorbance when there's a color change. Now here there's not obvious color change, but there's obvious in terms of the transparency in the solution. So you should be using the transmittance method. Okay, so when you do the setting, make sure you set into the transmittance functions. Okay, so that's about it. I hope this video helps you to guide you through the microbiology experiment. So at all and don't give up. Thank you and bye bye.